Thank you all for being here. I know Werner's doing a keynote right now, and so I will channel him a little bit and talk about one of his famous quotes, everything fails all the time. I want to highlight the second part of that quote, that build for failure and nothing will fail. Having your applications not fail is pretty standard for all of us that we want to build. And it's really important in a lot of domains, but it's most important, I would say, when you're building humanitarian workloads, things that are meant to help people in need during a catastrophic event. In our world today, unfortunately, we live with constant humanitarian crises, and so we want to be able to build our applications to meet the needs of our users who are suffering in one of these events. It's not okay for a 404 or a timeout when someone is calling for help in an emergency like a flood. And so having high reliability and resiliency is really crucial in these humanitarian workloads. And as builders and operators of these workloads, we need to prioritize building in resiliency when we go to develop our systems. And so you don't need me to tell you that building resilient systems is hard. Things that are highly available, self-healing, maybe even multi-region, these are complex technical tasks that need attention and effort. And so what we want to talk about today is how we can leverage tools like generative AI and in particular agentic AI to help make that easier for us. How can we take these new tools to help improve the resiliency of our workloads? And so before we get into the actual building of this agent, let's first go over some basics of resiliency so that we have a common lexicon as we're going forward. As we think of resiliency at AWS, we have this mental model broken into three different parts. The first is around high availability. This is the concept of how can our primary application, our active site of our application, withstand common failures that might impact the availability of our service. These are things like a server going down, a network interruption, things like that, if we want our applications to be highly available, we want it to be able to be resilient to these common failures that happen pretty much every day. The second topic is around disaster recovery. This is on there is a major impact that is influencing our primary site, and so we need to fail over to a secondary site, and how do we do that? So this would be a disaster hits your primary site of your application, where it is no longer able to serve traffic, and so you need to fail over to a secondary location, and how quickly are you able to do that, and how are you able to then serve that traffic from your secondary site, and then also the fail backwards, right? Fail back over to your primary site once the event is over. And so then the third component is the continuous improvement of your applications over time. So we all know this is true for new features, improving performance, but it is still as critical for resiliency as well. Once you launch an application, it's not done, it's not static. You need to be able to also improve the resiliency over time based off of learnings of failures that will happen in your application. So taking the learnings and the hard lessons from failures that you withstand, putting it back into the application, and then just over time, as you add new features, new problems can arise, and just building over and over, iterating on that to improve it. With that mental model in mind, we then have different categories of failures that we define. So these 5 categories are those buckets where errors will occur, failures will happen. And so we bucket them into these 5 categories for ease of identification, but also for remediation. So starting with the first one, most people are familiar with this. This is single points of failure. So in your design of your application, if there's any component that is by itself or running on a single box, anything like that, where if that component were to fail, it brings down your application and you have a bad day. So when we're looking at this, we're looking at how do we expand that single point of failure to be not a single point, but have redundancy in it so that it can withstand any individual failure. Next is excessive load. So looking at, is our application able to withstand a sudden increase in load and not collapse under its own weight? So this could be anything from making sure you can scale elastically, either ahead of the load or in response to the load, and also making sure that you have the headroom, whether it be service limits within AWS or whatever capacity you might need to start to accept and handle that traffic. Next is around excessive latency. So is our application built to withstand any kind of network interruptions? Are the timeouts that we're building within our code able to accept, sometimes it's 5 milliseconds, sometimes it's 200 milliseconds. Will our application handle that increased latency of different calls between dependencies and be successful in handling that kind of unknown, or not start to think that other parts of the application are down if you have an increased latency somewhere in your chain of dependencies? Next is around misconfiguration and bugs. Pretty self-explanatory. Is there a bug in your code? Is there a misconfiguration in one of your dependencies? These things, always happen, right? And so, are you able to either roll back a deployment, or are you able to put out a patch in time to prevent any kind of issues from cascading as you move along? And then the final one is shared fate. So do you have any common dependencies across applications such that a failure of one of those common dependencies starts to impact outside of its fault isolation zone, where multiple applications will start to fail because of a single component having an issue? So with these categories in mind, if you took notes, great, they will show up later. As we start to look at how can we identify areas of improvement in our applications, these 5 categories will be the framework for which we're looking for improvements and identifying remediations where there are problems. So as I said earlier, we are looking to build an agent for us to help identify these improvements. And so I know you've been beaten over the head with it all week, but just in summary of agentic AI, we are building an agent to have agency. It will be able to take autonomous action on our behalf to investigate our workloads using the foundation model for reasoning, and then a list of tools that we're giving it so that it can take action within our account, look at the applications that are running, take action to find the documentation that is necessary for it to provide recommendations, and then have an assessment of our workload overall. So a quick architecture diagram of what we're building. It's fairly straightforward. We are building this agent. Mike will go through how we're building it in our code. But as a quick summary of it, we are leveraging a foundation model from Amazon Bedrock. We are calling our inference is coming from Bedrock. And then we are creating a couple of tools that Mike will go through, but we're also leveraging existing tools by AWS. So the 2 that I want to call attention to are the Cloud Control API. If you're not familiar with this, this is an API that just exists for AWS, where you're able to do CRUD operations against your account and against your environment for creating any resource, reading a resource, anything like that. And then the AWS documentation. So both of these are tools that we'll be leveraging existing MCP servers, or Model Context Protocol servers, that AWS runs to access these resources. And Mike will kind of walk through how that works within the code, but we are just reaching out with our agent to these existing tools so that we're able to look at an existing CloudFormation stack within our account and evaluate that stack, and then use the AWS documentation to provide specific recommendations on how to improve. So being able to look at the current state of our account and of our applications, and then give us specific actionable things to do based off that feedback. So one last thing before we get into the code. We'll be looking at an application running in Mike's account. This particular application not really important what it does, but as you start to see the recommendations that the agent is giving us, I just want to give you a little bit of context. This particular application is for an agent that is providing food assistance based off a blog post that Mike wrote a couple months ago. But this isn't super important for the talk, but just give you context for what we're looking at as the agent goes through. And so with that, Mike, over to you.
All right, so let's build something. All right, I'm going to build this in Strands Agent. And by show of hands, have any of you built anything in Strands Agent before? Nobody? Awesome, then you are in the right place. So I'm going to step you through the build of all of this, and I'm going to explain what we're doing and how we actually built this out. And I'm going to be creating two pieces. The first is the actual agent that goes and uses the Cloud Control API, that uses an AWS documentation MCP server. It will go to my AWS account. It will pull back resources. It will reason about what's in my account. It will pull back relevant documentation around those 5 areas of resilience we talked about, and it will then generate a report for me, kind of like a report card where I can see, okay, what is the resilience of this workload? And as I change my recovery time objective and recovery point objectives, I'll be able to get insight into whether the workload does or doesn't support some of those requirements that I have. All right? So the first thing I've done is I have created a really basic agent here. And if you look at the agent, you can see that my prompt is, you are an AI-powered AWS resilience expert analyzing and enhancing fault tolerance and recoverability for mission-critical applications. Provide actionable, insightful guidance to identify vulnerabilities and implement robust solutions aligned with AWS best practices and specific business requirements. You generate all output in a GitHub Markdown format. Okay, so you can have your output in lots and lots of different ways. I arbitrarily decided that for this solution, I wanted it to output in a GitHub Markdown format. Great. Now, when you create an agent with Strands Agent, there are really 2 methods that you have to have. And let me show you the easiest one first. Really the smallest one is you need to have a method that returns the status. And in this case, I'm calling this my ping method. And what this does is it just returns healthy. And I decorate that with this decorator, app.getPing. And so that tells Strands Agent whenever a request comes into the /ping URL, it will return status healthy. That's the first method I need. The second method I need is an invocations method. And this method is a post, and it returns on /invocations. Okay? And this method is really the heart of my agent. So anytime a request comes in, I look at any JSON that's being passed in. I'm expecting a JSON element called message. That's my prompt that I'm passing in. I'm going to take that, and that's my prompt. And I'm creating an instance of an agent. An agent is a built-in class in Strands Agent. Okay? It allows me to create essentially an agent like we've talked about. And my system prompt here is just this system prompt that I showed you up here earlier. Okay, yeah, you are an AWS resilience expert. And all I'm doing is I am creating, I'm passing that agent my prompt, whatever prompt is that it's receiving here in that JSON messages object. It's generating the result, and I display the result in a JSON format. Okay, so right now, this doesn't do anything particularly useful, but this is really the building blocks of a much, much more complex agent that we're going to be building through this. All right? Now, when I run this agent, this will be running, if I run this locally, this will be running on port 8080, and if I want to invoke anything, like if I want to call that ping method, I've got to call, I have to curl to get/ping. If I want to actually invoke this, I have to perform a post to that /invocations. And so just to make this easier, I am going to create a Python script that allows me to easily interact with my agent. And let me show you, actually let me just save that file there. Let me show you what this file looks like. Okay, pretty straightforward. I've got one method to clear the screen. My main method here. When I start it up, it's going to say resilience advisor. It's going to have a bunch of equal signs. It's going to give me some instructions around how to quit. And I am creating, basically I'm going to be running in a continuous loop, okay, while true. And it's going to ask for some user input. Whatever input I give it, it's going to create that JSON object with that message. So really what this user input is what's the prompt that I want to send to my agent, right? It's going to send that in or create a JSON object with that. I've got some kind of administrative things here, and then it's going to perform a post to my agent that it's running at /invocations, and then if I get a 200 back, then I'm going to clear the screen, and I'm going to print out the results. Now remember that I set up my agent so that it's printing the results, or it's generating the results in a GitHub Markdown format. And so I'm using some libraries here to nicely print out that Markdown format, okay? So let's just run this and see what this looks like. Okay, so I've got two consoles here. Now, in the real world, if I was running this in production, of course I'm not going to run this in a console. We'll talk more about how to actually operationalize this in a bit. But just so that you understand how this is all working, you can see how all the pieces work together. On the right-hand side, this is my agent. So I'm going to run my agent. And you're going to see it is running on port 8080. And on the left-hand side, this is my client that I'm using to interact with my agent, okay? So you're going to be able to, because I've got both of these side by side, you're going to be able to see me issue commands through my client. You're going to see those go to the agent. You're going to see the agent process, do some stuff, and return the results back to the client. And then the client will display the results, okay? Okay, so I've got a prompt. Well, you know what? This is a resilience talk. I want to improve the resilience of my workload. So let's ask it something. I have a workload with the tag of AWS, CloudFormation, stack name, and value of food agent. Help me understand the resilience of my workload. Okay. So that request is going off to my resilience agent, and you can see here how it's processing. It's going to be doing some stuff. It's reasoning about my request, and in just a moment, we'll get some results back. Now, all right, so here's my results. So let's look at this really quickly. So it says, I'll help you analyze the resilience of your food agent. And if we look through this, okay, it tells me what to do. Here, you can look at CloudFormation. Here's some things to look at here. Here's some, think about multi-AZ deployment. This is not useful, right? This is not looking at my workload. So I built a really simple agent, but it doesn't actually do anything super useful right now. So let's take this to a next step and actually build something that's kind of useful. Okay, so let's clear this out. Let's go back and see if we can improve our agent a little bit. Oops. Okay, so I've made some updates to my agent here. Let's look through and let me show you what I've changed. Notice my system prompt is a lot bigger than it was before. So I've got the same basic system prompt as you originally saw, but now I've got a few other things. Perform only non-mutative actions when using the Use AWS tool. Okay, we'll talk more about what that means in just a moment. Critical, when analyzing a workload, provide your response in exactly this format. I want it to look like this. RPO analysis, classify as high, medium, low, and brief justification. You remember those 5 areas that Matt talked about for resilience? Yeah, you remember it was the acronym SEAMS. S stands for, anyone remember? Single points of failure. My first E was for excessive load. Next E was excessive latency. The M was misconfiguration and bugs. And the S was shared fate. I'm calling them slightly different things here, but I'm asking this resilient agent now to generate my results according to those 5 categories that are really the properties I need to have a resilient application. And I'm asking it to give me a letter grade, because really what I want to be able to do is I want to be able to look and see, okay, for redundancy, is it an A, B, C, D, or F? And that helps me be able to really quickly express to my leadership whether we need to invest some engineering work or not. Okay. The next thing, now you may remember from the previous example, I hadn't actually specified the large language model that I'm using. I don't know if you noticed that. Well, so here, I'm actually telling it what LLM I want to use. In this case, I'm using Sonnet 4.5. And I'm setting this up as a Bedrock model. So I'm using Bedrock, I'm using the Sonnet 4.5 model through Bedrock, and I'm setting my temperature, and there are lots of other parameters that I can set through this as well. Okay, I'm going to skip this letter grade for just a moment, and we'll talk about this more in just a moment. Okay. All right, so let's get down to my invocations method, where I actually invoke my agent. Okay, same kind of thing as before. I'm getting some input from the user. I'm creating an agent here. And this part right here is a little bit different than what you saw before. When I create my instance of an agent, I'm telling it to use my Bedrock model that I set up earlier. So that's how it knows to use Sonnet 4.5. That's how it knows my temperature and all those other configurations. It's using the same system prompt, but now I'm giving it access to a set of tools. And I'm telling my tools I want you to use are the use AWS tool and the calculate letter grade tool. Okay? So this is the fundamental part of how agents work. I give it access to an LLM, and I give it access to a set of tools. And in those tools, the agent can if the agent understands what the tools are, it can reason about what it needs to do to solve the problem that's in the prompt. Okay, so let's now talk a little bit about these tools. Okay, so the first tool is the calculate letter grade tool. That's this guy right here. I created a method called calculate letter grade. And my idea behind this calculate letter grade is I wanted, like I said, to be able to really quickly see for shared fate, is my letter grade A, B, C, D, or F? So then I have a quick sense for whether I need to invest some time and effort to improve that. And honestly, this is probably kind of a naive method, but it works well enough. You can see that I am asking for number of critical vulnerabilities. And these are critical resilience vulnerabilities. The number of high resilience vulnerabilities, the number of medium resilience vulnerabilities, and the number of low resilience vulnerabilities. And I'm giving some definitions here, and I'm doing these definitions so that the agent can reason about what this method is and how to actually use it. So you can see I'm saying this calculates a letter grade based on the number of resilience issues in the workload. A workload with a low RTO RPO will have more resilience issues than that same workload with a high RTO RPO. Okay? In other words, if I have a recovery time objective, a recovery point objective of 4 days for each of those, I can have a lot more resilience problems there than if I have a workload with a 2-minute recovery time objective and a 2-minute recovery point objective. All right? I'm defining what each of those inputs are for the critical, high, medium, and low resilience vulnerabilities. And then my method is really, again, pretty naive. If I have any critical resilience problems, I'm saying the workload has a D. If I have any high resilience vulnerabilities, it's a C. Any medium resilience vulnerabilities, it's a B. Otherwise, it returns an A. Now, the only thing I need to do to mark this as a tool for an LLM to start, or for my agent to start using it, is I simply put @tool. And that's using the Strands SDK. Okay, so it makes it super, super easy to write tool definitions and get those to work with your LLM. All right, so now remember, when I look at my agent and the tools I'm using, so I mark that method with @tool, and then I give it the name of the method here. Now this next tool, the use AWS tool, this one is kind of interesting. if I look at where this is defined, if I look at the libraries in my imports here, this is built in to the Strands SDK. So there is a use AWS tool as part of Strands tools. And so you think about all the stuff, if you had to connect to your AWS account, all the gunk you'd have to build to do that. You'd have to pull out your credentials. You'd have to go to the Cloud Control API. You'd have to then determine which method of that to call to find each of the resources in your account. Well, I don't have to worry about that because the use AWS tool does all that for me. All right. Should we run this and see how this actually operates? Okay, so I'm going to run my agent here. Should look the same as before. And I'm going to run my client, and let me ask the same question as before. I have a workload with the tag of AWS, CloudFormation, stack name, and value of food agent. The RTO is 24 hours and the RPO is 12 hours. Help me understand the resilience of this workload. All right, and what we're going to see now, you can see that the agent now says, all right, I'm going to help you analyze the resilience of your workload with this tag. Let me start by discovering the resources in this workload and assess them. And now you can see tool number 1, use AWS. Tool number 2, so it is actually going out to my account and retrieving results based on that tag. And it's smart enough to realize that, hey, I used a tag that's used in CloudFormation, so it's intelligent enough to realize it needs to go to CloudFormation to figure out that workload and inspect the stack. And then once it's retrieved those results, then it's going to start reasoning about that workload and calculating the letter grade. And you can see through the output here that it has called the calculate letter grade tool a couple of times. And again, it's continuing to reason about that, and should hopefully get results here in just a second.
And so, Mike, as we're going through this and we're looking at that use AWS, like you were saying, because it's built into the Strands agent, you don't actually need to say use the Cloud Control API. It knows if I'm looking at a CloudFormation stack, I need to use the Cloud Control API to be able to list resources, understand the stack itself. And in your prompt, you'd mentioned that you put in only use non-mutative calls to the Cloud Control API. So as we said earlier, the API itself is full CRUD operations, so you could create a resource, you could update a resource, but you're specifying, hey, only do read-only, so that we're just reviewing our application and we're not actually making changes in this exact agent.
Exactly. Now, and one of the reasons, and I think that's a great point that you bring that up. One of the things that, one of the reasons that I said use non-mutative API actions is, well, I'm running this locally and I'm using a profile that has administrative access, right? I'm sure many of us are a little bit sloppy in our engineering and we're full admins when we're running locally, right? But when I actually run this, if I were to actually deploy this in my account and have it be an agent that I'd want to interact with over time, I definitely don't want to give it admin access, right? So I could make sure that over time, when it's running in my account, I assign a role that only has read-only permissions. So I think that's a great point that you bring up there. All right, so you can see that we got some output here. Let's look at the output. Let me scroll to the top here. And you can see it's done some analysis here. Redundancy, it gave me a D. Sufficient capacity, it gave me a D. Timely output, it gave me a D. Correct output, it gave me a C. Fault isolation, it gave me a D. And it gave me some problems that I might need to look at here. But you know what? This workload has a recovery time objective of 24 hours. Now, if you don't remember what RTO or recovery time objective means, that really means how much downtime is acceptable for this workload. And when I talk about my recovery point objective, or RPO, that's how much data loss is acceptable to me. So, I'm saying that I'm essentially willing to have up to 24 hours of downtime and up to 12 hours of data loss. So this feels like a pretty low risk application, right? These grades don't feel quite aligned with what I've got here. So let me just ask it, do these grades really reflect the RTO and RPO that I provided? Okay, and this is my result here. I don't have any context about previous grades or RTO, RPO values that you provided. What? What's going on here? Anyone have any ideas?
Is there a session state in our agent?
Oh, we don't have any session state. So that's probably the issue, right? Okay, so what that essentially means is that every request I'm making to this agent endpoint is independent of any other request. So I asked it to look at my workload, it gave me a lot of results, but if I want to ask any follow-up questions, I can't do that because it doesn't remember the previous interaction. Okay, so we obviously need to add some session state here. So let's add that as a next step. All right. Okay, so let's look at this and I'll show you what we ended up changing. So we have the same system prompt as before. We didn't make any changes to the system prompt. We've got the same LLM, the same Bedrock model thing we've done before. Our calculate letter grade is the same. Let's see. But there is something different here, and I'm trying to remember. I'm trying to find it in the code here. Okay, there is one thing that we added here. I added a bucket name. Okay, the bucket is where I want to store my session data. Okay, so in this case, I have a bucket in my account called reinvent session data. That's where I'm going to be storing my session state. Now, if I go into the actual agent invocation here, you're going to see now I'm going to try and, so I'm getting the prompt from the user, and then I'm going to try and get the session ID from the user. I'm expecting that client to pass in a session ID. I'm going to get their session ID. If they don't give me a session ID, I'm going to raise an exception and return a 400 HTTP code. I want to write out the session ID, and then I'm creating an instance of an S3 session manager. So this is a built-in object to Strand's agent. And you can see here that I'm passing in the session ID, that ID that's coming through from the client. I'm telling it the bucket name, and there's a prefix in that bucket where I'm going to be writing my session data. I've got a prefix there that I'm just calling prod. That's where all my session data is going to be going. And if you look at my agent, all I'm doing is I'm adding a session manager. And that's it. And I should hopefully have session data by doing that. Now, the last thing I really need to do is I need to go to my interactive file here, and I need to update this to provide a session ID. So all I've done here is I've created a session ID, which in this case I'm just using a UUID. And then I'm just adding that to the payload that gets passed in to my agent. All right, so let's try this again and see how this works. All right, so let's clear this out. All right, so let's try this again. I have a workload with the tag of AWS, cloud formation, stack name, and value of food agent. The RTO is 24 hours, and the RPO is 12 hours. Help me understand the resilience of this workload. Okay, so we're going to see the same thing kind of happening, but one thing you will see here, though, is now I've got a session ID that's being emitted to, emitted from my agent, so I can see that I'm getting in a session ID. We're going to see the same thing where it's going to pull resources from my account. It's going to reason about my workload. We're going to get hopefully the same result as before, and then now I should be able to ask it follow-up questions to validate what it's actually producing. Okay, so you can see here now you can hopefully see some calls to, it's moving too fast, calculate letter grade. You can see now it's reasoning about that workload. It's already pulled everything back about it from my account. It's reasoning about it. It is providing some, it's reasoning about it, so it's providing some recommendations. It's now creating the output, and I should see that output in just a second here. And do you all remember what my grades were before? It seems like it was mostly like C's and D's, right?
They weren't great.
Yeah, it was not great. And if I look through this, okay, looks like C's and D's. Redundancy, D. Okay, well let's ask it a follow-up question. Given my RTO and RPO, are these grades accurate? You can see that it is printing out my session ID, so it's using the same session ID, so I've got that context now. And I don't know if the agent's moving pretty quickly, but if you're able to see that, it made a comment, hey, you're absolutely right. Those grades don't make sense. Let me recalculate for you.
And something we don't do here, Mike, but you can totally do depending on how you want your client, how your user to interact with the agent, would be to change how you stream back responses to your client, right?
I think that's a great point. I am waiting for the complete result to be done before it comes back to the client. Yeah, but you're suggesting probably streaming would provide a much better user experience.
Exactly. If we wanted to have that, more interactive feel, like in a more chat-body way,
yeah,
being able to stream tokens back as soon as they're being generated would help to kind of improve that user experience over time. But for our purposes here, not super necessary.
Yeah. No, but I think that's an excellent point. Definitely streaming that would provide a much better experience here. All right, so let's look at what it returned to me. Gave me a lot of results. Let me just go to the top here. Okay, you're absolutely right to question these grades. With a 24-hour RPO and 12-hour, or 24-hour RTO and 12-hour RPO, many of these issues I flagged as critical are actually nice to have or optimizations. All right, so then it said, now my redundancy grade is a B, my sufficient capacity grade is a B, my timely output is a C, my correct output is a B. Okay, so it looks like most of my grades are now Bs and Cs, which I think seems more aligned with reality. Okay, so now let's take this a step further. So you think about, there's a couple of things that we've talked about here. So first of all, in terms of tool use, I've shown you how to use a tool that's built into Strands Agent, the Use AWS tool. I showed you how to use a tool that I created myself, that Calculate Letter Grade tool. The next thing I think is valuable to use is there are a lot of tools out there that are MCP servers. How do I actually integrate an MCP set of tools into my workload? So let's look at doing that. We also showed you how you can have more interactive conversations through things like Session ID. But I feel like there's still some problems with my prompting here because I don't want to have to ask it, hey, are you sure that these grades are right? Are you sure that the way you analyze this is correct? That's not a great experience, right? I really want it to give me the correct results the first time without me having to really quiz it and challenge it on every single thing it brings up. So in terms of next steps, I definitely want to add an MCP server. And I definitely want to improve my prompting so that I don't have to challenge it on everything. So let's go ahead and try to fix those kinds of things. All right, so let's stop these and clear these out. So let's go to my agent. And I made a couple of changes here. Let's look at the changes that I've made. The first change I made, remember before I had my prompt embedded in this file here. I've now taken it out and I put it in a separate file. I'll show you this prompt in just a moment. Can you think of any reasons why I might have done that? It's easier to maintain, maybe. I mean, there could be a lot of reasons. For me, it's easier to maintain. You also are going to see that, as your prompt gets bigger and bigger and bigger. One thing that I see a lot of organizations deal with is they'll complain about how, I got my agent and it does okay most of the time, but then it'll sometimes do things I don't really want it to do, or I don't see maybe some of the consistency I want. And oftentimes when I see that, if they're using a model that has good direction following ability, usually when I see that, it means that maybe you've got things in your prompt that are vague enough that the model needs to fill in the gaps. And so if it needs to fill in the gaps, then it's going to do things you may not expect or may not anticipate. And so that usually requires that you add more specificity to your prompt, which means that your prompt itself is going to get larger. As your prompt gets larger, if it's embedded in your code, then after a little while, most of your agent file here is going to be prompt. So that's why I broke that out. We'll see that more in just a moment. Okay, so then the next thing I did is I want to use the AWS documentation MCP server. Any of you familiar with this MCP server? It is like my #1 favorite MCP server. And the reason it's my favorite is because all it does is it returns documentation and blog posts on AWS content. Okay? It's curated, managed by AWS. This went generally available about a month or two ago. It's awesome to use. And if you want deep, curated documentation, this is a great way to go. So this is my code to use that MCP server. I create a variable called AWS doc MCP client. I create an I use an MCP client object, and I give it the URL of that MCP server, which is knowledge-mcp, whoops. So you can see it right there. And this MCP client object really defined right here. So it's built into the Strands tools. All right. So that's how I get my MCP client for that documentation server. And then to actually use it. I've made then a few other changes here. The first time somebody runs this code, I really want to be able to ask, okay, what's the tag of the workload that you're interested in? What's the value of that tag? What's your RTO and RPO? Because those seem like the natural first questions this agent's going to want to know. Once I understand that, then I can actually process and do some other interesting things. So I've updated this code to retrieve a tag name and tag value if they're there, to retrieve an RTO and RPO if they're there, and then create a prompt, something like, hey, this user workload is running in AWS. It's defined by the tag, defined by tag name. The value is tag value. The RTO and RPO are this and that. The only other thing I've done here is, if you look at my agent, well, before my agent, I have this AWS doc tools variable that I've created. And remember that variable before, the AWS doc MCP client. That's my MCP client. All I do on that is I call list tools sync. And what that command does is it goes out to the MCP server, it pulls back the tools that that server supports and puts them in this AWS doc tools variable. And then I just add that AWS doc tools variable to my list of tools. And that's literally all I have to do. It's so stupid simple, okay? And I love stupid simple. All right. Now, the next thing I want to show you. Let's show you my system prompt. This prompt now is 145 lines of code, or 145 lines of text. So let's read through not everything here, but just give you a sense for what I'm doing here. First thing, I give it a purpose. Whoops. You are an AI-powered resilience expert. Okay, we've kind of seen that before. I give it a persona. You should embody a seasoned cloud architect with 10 years experience designing and optimizing distributed systems, communicate with authority, precision, approachability, ask probing questions, offering tailored recommendations that inspire confidence. I'm giving it a grading philosophy. So you saw some of the problems I saw with my grades, right? Where it generated grades for me. They didn't seem consistent. I asked it, are you sure? And it said, you're right, I'm not sure. Let me try that again. So I'm giving it some directions on how to actually grade. Because if you think about it, I say, give it a letter grade, A, B, C, or D. But there's a lot of things that the model has to assume in all of that. So I'm providing it that specificity of what I want. So I'm giving it this grading philosophy. Grades reflect how well the current architecture meets the stated RTO, RPO, not absolute architectural quality. Give it some core principles. The same architecture receives different grades based on RTO, RPO, and I give it some examples. I give it a grading scale. What does an A mean versus a B versus a C versus a D versus an F? Again, you can see how, as a human, when I wrote that first set of prompts, there's a lot of things that I'm taking for granted, where this model is having to make some decisions on its own about, okay, what does Mike actually mean when he says an A? Well, what I'm saying is A means significantly exceeds requirements. It may be over-engineered. That's much more specific and actionable by an LLM versus give me a letter grade. I'm giving it some requirements for my RTO and RPO. A high RTO, RPO means I have hours to days of tolerance. I give it some examples. A medium means I've got minutes to hours of tolerance. A low means I've had seconds to minutes of tolerance. I give it a grading matrix. For high RTO, RPO, these are things I would expect to see. For a medium RTO, RPO, these are things I would expect to see. And for a low RTO, RPO, these are things I would expect to see. I give it some directions for tool usage. When calculating letter grade, you must always include the RTO, RPO in the context of the assessment. Frame the evaluation as, for X hours or minutes of the RTO, RPO requirement, this setup meets, exceeds, falls short. And I give it an example here. And I say, never call the tool without explicit RTO, RPO context. Then I have a grade verification. After calculating each letter grade, internally verify, is grade X appropriate for the current architecture for the given RTO, RPO? And if it's inconsistent, recalculate. Now, again, I'm hoping you see all of the areas that the LLM was having to essentially guess what I meant. Resilience definitions. I asked it before to categorize my resilience posture in those 5 areas. But you'll also remember that I never bothered to explain what those 5 areas actually meant. So here, that's what I'm doing. Redundancy means I'm eliminating single points of failure through component or system redundancy. You can read through all of those. Now that I'm using that AWS documentation MCP server, I have specific directions around how do I want it to generate documentation. For me, I want it to give me, essentially what I'm trying to achieve here is I want to have good recommendations, and if it's telling me that I need to maybe set up Lambda reserve concurrency, I don't want it to give me a link to the Lambda landing page. That's not useful. right? But a link to the documentation on how to set up Lambda reserve concurrency, that's actually useful. That's what I'm trying to get at here. So that's what I'm saying here. So provide specific AWS documentation links to support all recommendations. Links must provide deep insight into the topic, not generic product pages. I give it an analysis process. So do this, accept the AWS workload tag value, classify the RTO, RPO as medium, high, low, execute only non-mutative API requests. For each resilience area, state, these things, calibrate all recommendations, format output according to the response format section. Now this response format section, this is probably what you remember. This is what we've been looking at. This is the same as before, except I've now added a section here around where I want my AWS documentation links to be part of this output here. And then I'm giving it some output rules. Be concise. Start immediately with formatted analysis. Don't include thinking tags. Present only the structured response without preamble or conclusion. Every grade and recommendation must align with the stated RTO and RPO. If the architecture exceeds the requirements, note potential cost optimization opportunities. And then I've got some final critical reminders here. Before finalizing any grade, ask yourself, did I classify the RTO, RPO correctly? Does this grade make sense? Would the same architecture get a different grade with a different RTO, RPO? Am I grading based on requirements fit, not architectural sophistication? All right, so really the thing I want you to take away from this is, well, by raise of hands, are any of you surprised by the complexity of this prompt? Few people? Yeah. And I hope you see that as you look through this, this is designed to take away the ambiguity that we originally had. And that's one of the key takeaways I want you to think of. When you see your agent not operating the way it should, ask yourself, how much is the agent having to come up with? All right. So let's actually run this. But before I do that, I need to update, excuse me. I've just updated my interactive page just so that it includes a few more things here. Let's actually just run this.
And Mike, as you're on that, I want to highlight as well that the complexity of the prompt and talking about breaking it out into its own file, all of that gives you the ability to really iterate on that prompt. We're showing you the finished product here, but that took a lot of time and execution and work to get it to that point. And as we're talking about the iterative process, it's not going to be a one and done with your prompt, but also keeping it out there as you try different models. For example, we're using Claude Sonnet 4.5, but if you use a different family of models, how you structure your prompt will be different. The kinds of tags that you give it will be different. And by treating it as just another asset within your code and within your development pipeline, you're able to more easily test things out and iterate as you move along to build out your agents.
I think that's a great point. And when you're building a prompt like this that can be a little more complex, a good approach is, say, you're using Claude Sonnet 4.5. Say you know what you want it to look like. You can go into an LLM. Like you can even go into the Bedrock console, to the text playground we have there, and say, hey, I'm trying to write this prompt. I'm doing this in Claude Sonnet 4.5. This is my prompt. This is my output, and this is the output I want to get. Help me get there. What I'd recommend if you do something like that, don't pick a Claude model. Pick a different model, a model from a different model family. You do that, and it can give you really good direction on how to do this. Hey, maybe you need to change your prompt to look like this or that. Okay, so now I've got my results here. These are now aligned with what I want it to look like. Hey, I've got my redundancy, my sufficient capacity, my letter grades here. This looks just like I want. Now, let's see if we can do something a little more interesting. Let me ask it, how do these grades change if I change my RTO to 2 hours and my RPO to 30 minutes? What we're going to see here is if you look at the agent processing, it already understands my workload. So it doesn't need to go back into my account. It's going to be recalculating those letter grades based on how it's reasoned about my workload. It's going to now go to the documentation. It's going to search and retrieve documentation, And in just a moment, we should see some results here. Now, one thing that's important to note is now you've all seen my prompt. I never gave it anything specifically to reevaluate grades based on a different RTO, RPO. But it's able to do that because it can reason about what's already there. And you're going to see in just a moment how I'm going to ask it some things that truly aren't in my prompt. Okay, and you can see, through here that most of my grades now are C's and D's for a lower RTO and RPO. Let's try something even more crazy. So I know that I have observability problems with this workload. I would like to know what are maybe the top 3 things from an observability perspective that I should work on fixing to improve this workload. So let me ask it, what are the top 3 things I should focus on to improve the ability of my workload? Yeah, now, you've seen my prompt. I've never mentioned anything about observability in the prompt, but it's able to, again, reason about my workload. You can see that it's searching the AWS documentation. It's going to reason about what it searched in that documentation. It's going to pull back results, and hopefully soon I should have something that I can actually action on. Okay, so give me some good information here. So if I scroll to the top, tell me number 1, I should implement CloudWatch alarms with automated alerting. Great tip, I don't have any alarms here. It tells me some ways I can do that. Enable X-ray with distributed tracing. Great idea, I don't have any tracing. Even gives me some code I could add. Hey, that's pretty cool. 3, implement structured JSON logging with CloudWatch logs inside queries. Cool, I do have a log file, but I'm not really doing much with it. These are all great tips, and it gives me some quick wins, some quick implementation steps, a lot of really interesting things. Let me just do one last thing here. I'm going to ask it to build me a runbook that I can use to recover from an operational event. Now again, remember, there's nothing in my prompt about building runbooks, but because it has access to these tools, it already understands my workload. It's able to search the AWS documentation. It's able to reason about that. It's able to reason about my workload and generate something that I can use that's actually pretty useful.
And as it goes through here, very much like we were talking about getting more specific with the core part of our agent, looking at doing that evaluation and recommendations. This runbook, if we're not happy with how it's displaying or the recommendations it gives, like Mike was saying, we can be more specific within our prompt, give it that option of, hey, if someone asks for a runbook, format it in this form, in this way, or provide these specific components of that runbook. But what we'll see here, it does a really good job without that. But if we want to get better, more specific, we're able to provide that within that prompt to help refine those outputs.
And if you're following along with what the agent is processing through pretty quickly, but if you're able to quickly read what it's doing, it's looking for, okay, maybe there is downtime, maybe somebody accidentally deleted something. There's a lot of different scenarios that it's thinking through how to recover. You can see, what if somebody accidentally deleted my stack? How do you recover from that? So it's pretty interesting. And so I could take this runbook that's generated, I could then add that as, add that to my recovery actions, add that to my documentation. And that gives me a good first step on, how to have better resilience here. Okay, so let me just scroll to the top here and we'll just scan through this quickly so we can wrap up. Gives me a lot of scenarios. Okay, what if you have S3 data loss or corruption? Here are some things to do. Let's scan through. What if you have, with your Lambda function? How do you validate that your Lambda function's running? And gives me when should I escalate to AWS support? Again, really, really good information here. And we've got just a couple of seconds left. So Matt, let's wrap things up.
Yeah. So, we talked a lot about all those different steps in building the agent itself. And we also alluded to, we're running all of this locally on Mike's machine. Great for him, not great for everyone else in our organization. And so how do we make that more usable by everybody? And so one really good way to do that would be to deploy this agent to Bedrock Agent Core, to use that runtime as a hosting platform for having this agent be applicable or be usable by everyone in our organization. And so we can just take the Strands agent that we've built, bundle it up, and then send it up to Bedrock Agent Core to host the agent itself. Everything that we've written can still reach out to those tools that he defined, but also his MCP servers. And then things like session can be handled by Bedrock Agent Core. Things like observability and tracing of the agent itself handled by Bedrock Agent Core. So it really helps us to refine or host this and make it more applicable for everyone else. And so from here, if you want to learn more about Strands agents, you can go up to the documentation using the QR code on the left. And if you want to get your hands on this code in particular, the QR code on the right will take you to our nonprofit's sample page on GitHub, where you can see all the code, get your hands dirty with it, and extend it for whatever you want to do. Maybe you want to include cost or performance optimization as a separate agent or separate tool for helping to improve your workload over time. And so I know this is the last session of the week as far as our nonprofit track goes, but if you do not know who your AWS account team is for your organization, use the QR code on the right here to get in contact with your account team and have access to SAs like myself and Mike if you need any help building this out or just want to talk about what you guys do and how we can help. One last resource is the AWS Skill Builder page. If you want to get your hands dirty with any other kind of resources that we may have talked about here today, go to Skill Builder, and there are workshops and other learning resources that are available to you for learning all about AWS. And with that, thank you so very much for your time.